All right, now in example 4, what we're looking for is the same thing. We're going to look at the graph, and we're going to see from this graph that's already on the paper that the way this is scaled, this is somewhere between -1 and -2, and this is somewhere between, well, actually, this one is somewhere between -1 and 0. This was somewhere between 0 and 1. And this is somewhere between 2 and 3. So it wasn't, it's not like the other two that we just saw in the last example, where we were able to see a nice spot. However, if you look carefully, and I think you can use your graphing calculator in a similar way, you use the second calc feature. So this is a fairly close-up view, and you can see that it looks like there's 4 vertical lines there, but there's really some curves crossing back and forth, making that function have turning points and come back to the x-axis after it goes way up or way down. But at any rate, these two had crossing points that were at least at rational numbers. Now, I'll tell you that I investigated the other two and found that they were not rational. In other words, not a fraction, not an easy fraction. But these two are easy fractions, and let me show you what we can do with that. So it turns out that we found this one to be -1/2. Okay. And this one, if you saw on the screen there, it said 0.6, which is the same thing as 3/5. Okay, so we have some nice fractions. So what we're going to do is we're going to start with -1/2 in the box, and we're going to divide that out. And so this is, again, this is nicely in order for us, and there were no gaps to where we had to put a 0. So 10, -11, -42, 7, and 12. So start by bringing down 10. And fortunately, this is all going to work out where we're not going to have to use any more fractions in here. So -1/2 times 10, that's -5. And then when you add the column, you get -16. Half of -16 is 8. This is negative times negative this time, so it's positive. And then adding this column, we get -34. And then -34 times -1/2. Half of 34 is 17. Add that column, you get 24. Half of 24 is 12, and it was negative this time, and it should turn out to be 0 if we did everything right. Okay, now we also know from what we looked at on the graph that 3/5 should also work in the box. So let's do 3/5 in the box. And if you don't like 3/5, you can use 0.6. That's fine. Okay, but now we're using these numbers that are left, because what we want is we want to get this down. See, this started as a 4th power, so this is representing 3rd power, and we want to get this down to a quadratic that we can either use the quadratic formula or some other strategy to solve. Okay, so we're doing this. We're bringing down the 10. And 3/5 of 10, or 0.6 of 10, turns out to be 6. Add the column, you get -10. And now this is going to be the same thing here, except it's going to be -6. And we add this column, and we're going to get -40. And then we add, -40 times 3/5 turns out to be -24. And we get our 0 remainder like we wanted. Okay, so now what we know is that we have x plus 1/2 is a factor. x minus 3/5 is a factor. And these three, that's representing 10x squared minus 10x minus 40. Those all have a common factor of 10, so I'm going to write that out here, 10. And then instead, over here, I'm going to put x squared minus x minus 4. So my 10 times x squared is the 10x squared, 10 times negative x, negative 10x, and 10 times negative 4 is the negative 40. Okay, but now we have these three factors. So we know the answers to these two, negative 1/2 and positive 3/5. We need to now know the answer to this one. Now that, unfortunately, there isn't a pair of numbers we can use that will have a product of 4 and a sum of negative 1. All right, so we're going to have to use the quadratic formula. So remember that that is the opposite of b squared. So the opposite of b is not squared. The opposite of b is positive 1 plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, so now, move that a little bit so you can see better. So now, what's all this under here? That's 1. We got negative 4 times negative 4, basically. Multiplying by 1 doesn't do anything, so that's 1 plus 16. So I think that's going to be 17. And so we have 1 plus or minus root 17 over 2. Okay, so as it turns out, if you do these two things with the plus and the minus, if you put this in your calculator, then you're going to get approximately either 2.56 if you use plus, or negative 1.56 if you use minus. Okay, so that's just from putting that in the calculator. And, 2.56, that right there, so this is about 2.56. And this is the exact value. This is the rounded off value. And this one right here is negative 1.56. All right. In the interest of time, I think we won't do the second example there. It's going to be, we would use the same sort of strategy as we did here, looking at the graph first to find some rational roots, and then dividing out to find the other two. So we're going to look next at this irrational conjugates theorem. You can see that on your paper. It turns out that, and you can probably see this from when you work with either the quadratic formula or completing the square, we often end up with plus or minus the same root. Okay, so when you have a irrational like a plus root of some number, in this case they're calling it b, then there's always another one that is just what's called the conjugate. Notice that it's not the opposite of a and the opposite of root b, it's just the opposite of root b. Okay, so the way that works is if you have this example, in this example, if we know that 1 is a 0, guess what? Okay, I misread that earlier. So anyway, if 3 is a 0 and 2 plus or minus, plus root 5 is a 0, that means 2 minus root 5 is a 0. If you know that 3 is a 0, you know that you have x minus 3 as a factor. If 2 plus root 5 is a 0, you know that you have x minus 2 plus root 5 as a factor. Now, if 2 plus root 5 is a factor, you know that you have 2 minus root 5 as a factor. So you have x minus 2 minus root 5. So subtle difference between these two. You're subtracting these zeros inside the factor on all of them. It's just that on this one we have minus root 5 and on this one we have plus root 5. All right, so what this is asking us to do is put together a polynomial function that would have these zeros. And we know that if you have this 0 and this 0, you also have to have the 2 minus root 5 0 also. That's a 5. Okay, now we need to multiply this all together. The one that's going to be difficult to do is let's multiply them together first, the two that have 3 terms. And you guys know that I like to use this box like a multiplication table when I have to multiply a multi-term polynomial to another one. So I just set this up like this so that we can make sure we don't miss any of our products. So this is, again, just like a multiplication table. So this is going to be x times x, which is x squared. This is 2 times x. This one is negative root 5 times x. This box is negative 2x. This box is negative 2 times negative 2, which is 4. This box is negative 2 times negative root 5. So that's going to be positive 2 times root 5. Down here we have x times root 5, or root 5x. This is negative 2 times root 5. And this one is root 5 times negative root 5, which is negative plane 5. All right, so our box is filled up, and now we can add up all the things that are on the inside boxes, but some of them are going to cancel out. 2x and negative 2x are bouncing each other out. Root 5x and negative root 5x are going to bounce each other out. 2 root 5 and negative 2 root 5 are bouncing each other out. And it looks like all we have left is x squared minus 1. That doesn't make sense.